Okay, sketch the graph of the inverse, they say. By far the easiest way to do this is to get some landmarks off the original function, and then we're going to flip them. So, for example, this original function goes through minus 10, 4. It goes through this point, which they're clearly offering to us, which is minus 6, 0. You noticed, I'm sure, that every one of these squares is worth 2, not 1, which is a weird and annoying way to label this, but whatever, we'll work with it. We go through 0, negative 6 down here at the bottom, the vertex, if you will. We go through 6, 0, and up here we're at 10, 4. The inverse will go through the opposites of each of these points. So the inverse will go through 4, negative 10. There we go. It'll go through 0, negative 6. It has that point in common with the original. That's weird, but okay. It'll go through negative 6, 0. Another one it has in common. It'll go through 0, 6. 1, 2, 3. And it'll go through 4, 10 up here. So while the original function was like an L shape pointing down, the inverse function is like an L shape pointing to the left. Or if you've noticed the way that x and y are always trading places when you do curves like this, here's something for you. The original was an L shape with the point toward the negative y direction, as in down. The inverse is an L shape with its point toward the negative x direction. Even in verbal descriptions like this, the x and the y trade places, and that'll happen every time. Here they have this original function which starts at negative 6, 0. It rises until 0, 4. That's the highest it ever gets. And then it falls off again to 6, 0. The inverse will go through the opposites of these points. The inverse will go through 0, negative 6. There we go. It'll peak at 4, 0. There it is. And then it'll come back down to 0, 6. Like so. So if you connect those dots, again, you can think of this original function as an arch with the bump pointing in the positive y direction, and the inverse is a bump in the positive x direction. So again, the x and the y flip around. Now, is the inverse a function? Inverses can be functions, but they certainly aren't guaranteed to be. And the way you check, you remember, is with something called the vertical line test, where you just draw a series, like a comb, of vertical lines like so, and you see if those lines hit your function more than once. If your function looks like this, and each line only hits it once, then no problem. Yes, your curve is a function. If your function does this, then some of those vertical lines are going to hit it more than once. And if that happens in even a single place, that means your curve is not one-to-one, it is not a function. So looking at this, immediately you can see curve A, my vertical line, pretend that's vertical, hits the inverse more than one time, so this is not a function, and B fails as well. It gets hit twice, and it gets hit twice in quite a number of places, so it's definitely not a function. Inverses can be functions, but it isn't guaranteed at all.